Welcome everyone to this topic on Docker tutorial for the beginners here. Now in this one we are going to talk about the various components. For example, what is the DevOps here, why the DevOps is important, what is Docker, the advantages of Docker, installation of Docker, architecture of Docker, components of Docker here. So these are the different things which we are going to talk about over here. Now let's start with what exactly is in DevOps all about here. Now DevOps is nothing but a collaboration between the development and the operations teams over here, which enables continuous delivery of the applications and services to the end user. So it's a combination or collaboration between the two teams, development and operations, which helps us to go for a further implementation of various processes like continuous integration, continuous deployment, continuous delivery. All these things are possible with this collaboration over here. Now, why exactly Docker is important for us as such? In a city far away from this one, so a developer decided to develop a tons of software on a single VM. Now he can put up applications. He is having a big server and he wants to host the multiple applications on a single machine. But for him, these virtual machine got a crash, because definitely if you are putting up more different applications as such on a single VM, it's not able to take up that much kind of load over there. So in order to avoid this situation, how exactly he can do the various options or what he can implement to have this issue resolved. So ultimately Docker is something which is the solution of him. So if he really wants to host multiple applications on a single virtual machine, or he want to have different applications, then Docker is the ultimate solution for him to do that. And by doing so, there will be no issues as such when we talk about that the errors or the virtual machines cannot be crashed, and there will be no impact on the virtual machine as such. So why exactly Docker is important? So let's talk about the comparison between the Docker and virtual machine. There are very few reasons why exactly the Docker is being chosen over a virtual machine, because virtual machine is a full-fledged component which can take up any kind of load. But some of the reasons are still that in which case we will be preferring the Docker instead of the virtual machine here. The very first one is the memory uses. So Docker is having a very less memory uses because there is no concept of guest operating system, whereas on the other hand the virtual machines are going to take a huge amount of RAM resources in order to keep that particular operating system up and running. Second one, performance, because if you have less utilization and the users is less, the performance will be better. But for some reason, if you are taking up more resources, and you will not be able to deliver that amount of performance as such over there. And then again we have portability. So portability is also quite easy when we talk about the virtual machines. In case of Docker, it's quite portable as compared to the virtual machine. And then the last time is that the boot up time. So virtual machine boot up time is probably in minutes, but in case of Docker it's in seconds. So if we summarize it on this one, so the memory utilization, the boot up time, the performance, everything is better in case of Docker as compared to the virtual machines, right? For a classic example, let's say that what about the memory user? 9 GB of memory is something. If you can see that app1, app2 and app3 is there. So green and red color represents the occupied memory and the wasted memory. Now there is a particular utilization of, let's say that a server which is available there, and 3 GB of RAM is something which is wasted, and 4 GB of RAM is something which is being occupied there. So app 2 is using like 2 GB, and then you can see that the specific 2 GB of RAM is occupied and 3 GB is occupied, and the wasted one is 1 GB. So VM can see over there that 9 GB of RAM is used, and the remaining 6 GB of unused RAM cannot be reused here, because if, for example, I allocate like 4 GB of RAM to the virtual machine, it's there itself, it gets logged on. So it's not like, okay, I'm using only 4 GB RAM out of this 9 GB of RAM, then the next 5 GB of RAM will be totally wasted. So you cannot reuse it for any purpose. So this is a problem with the virtual machine, that if you allocate some memory to the specific virtual machine. If you are not using that much resources or that much memory, the remaining memory will be simply wasted, because this is hardcorely allocated to the virtual machine and you cannot utilize this unused memory as such over there. So this is the limitation from the memory perspective. But in case of Docker, definitely if out of the 9 GB of RAM, if we are using only 3 GB of RAM, so whatever the unused memory is there, so we can actually reuse it for the new containers. So it's not dedicatedly allocated to the virtual machines. If you are using out of 9 GB, if you are using 1 GB, 2 GB, 3 GB or 4 GB, whatever the remaining memory is available, that you can simply use it for the other containers also. This ensures that you always go for an optimal utilization of your resources, and unnecessarily there is no wastage of the different resources or the different components over here in this one. So that's the reason why the Docker containers are quite efficient in terms of memory when we compare it with the virtual machine. Next one is the performance. Now in a virtual machine, we know that on the infrastructure, on the physical infrastructure, on top of that you put up a kind of operating system, a base operating system is there, and then on top of that you have the hypervisor, and this hypervisor then is used to create the virtual machines, which is having a kind of guest operating system inside it. Now the issue over here is that you have two operating systems over here. So the guest operating system is also going to take some particular resources, and for example the memory or a space, a processor. So in every resource terms, it is going to go ahead and say that okay, I'm going to use the particular some of the resources. Now problem is that if you are hosting a very small application, you will end up in having a more consumption, because of this guest operating system will take more of the resources, and then you are just using some very small resources for your application in an real world. So Docker container on the other hand does not have a concept of the guest operating system, and that's where what happens, that the Docker engine is more than sufficient to handle the Docker containers, and inside the Docker containers there is the application which is being hosted over there. Now with this one, definitely the performance is quite better as compared to any virtual machine, because of the terms that there is no unnecessarily wastage of the resources. Because in the previous case, virtual machines, a full-fledged guest operating system is up and running, you need some resources to be allocated to that. But in case of containers, you don't need to have that particular functionality implemented. Then portability. So having a portability or moving an application which works on a system A does not mean that it will work on the system B also. This is a similar problem which we face, that usually the application works perfectly fine in a lower environment, and when it goes to the production environment, it sometimes fails and it does not comes up properly. So this is an portability issue which we have when we talk about the virtual machines. But when in case of containers, when we got a container up and running in a lower environment, and once the container is prepared, you don't have to do the changes or modification to that depending on the environment. The same container can be deployed to production environment, and it's very easy. So whatever container prepared in the lower environment in a dev environment, the same will work in production environment without any issues, because it contains all the dependencies and executables, everything inside it. So you don't have to do any kind of modifications or changes to these containers as such over here. And the last one is the boot up time. So the boot up time of the virtual machines is in minutes, and whereas the boot up time of the Docker containers is in seconds or probably in milliseconds. So these are the reason why we consider the virtual machine as an resources based environment. But on the other hand, Docker is something which is quite light and fast as compared to virtual machines. So let's see that what exactly is in Docker all about here. So in this one, you can see we have the physical infrastructure on which we have the host operating system. Now we don't have the hypervisor and the guest operating system. Instead of that, we have the Docker engine, which is taking care of managing the Docker containers, and inside these Docker containers you have the applications and all the required binaries and the libraries here. So there is no concept of the guest operating system. This Docker engine is the person, or is the process which is taking care of all the requests which is going on, and if this Docker engine is up and running, then all the containers will also be accessible and will be available. Now, Docker is nothing but a OS level virtualization software platform that enables developers and IT administrators to create, deploy, and run applications in a Docker container with all its dependencies. So Docker is a very important tool nowadays if you want to look forward to host your application, because of its portability benefit that you don't require much of the changes depending on the platform or depending on the environment. So whatever the developers are able to build up, the same thing will go till the production environment. Now let's talk about what exactly is in Docker container here. Now Docker container is a lightweight software package that includes all the dependencies, whether it's a base operating system, some framework, some libraries. It's something which is a part of this one, so that if you want to host your application, you will be able to do that. So it's a complete package. So both the source code and the dependencies is what you put up inside the Docker containers. Now within these Docker containers, you can have multiple applications there, multiple programming languages, multiple frameworks can be hosted there. In fact, the databases also can be hosted within these Docker containers. You can host them as such over there. Now, what are the different advantages of Docker? Let's talk about that. Now, the first one is the rapid deployment. So, rapid deployment is the very first advantages which we are getting over here. Second, quick and easy configuration, better efficiency, portability, scalability, and security over here. Now there are different ways in which we can understand the benefits, or we can have the understanding about the Docker here. So these are some couple of benefits. Now let's take them one by one. The first one is the deployment part. So it supports the rapid deployment. Now just like a web application, for instance, I want to deploy to website, so there are some couple of steps which needs to be done across different environments. Like for example, if I have 5 environments, I have to do the deployment, the same steps in all the 5 environments at the different period of time. Now when we talk about Docker containers, we don't have to run those steps multiple times, because once those steps are executed in one Docker container, the same Docker container goes till the production environment. So you don't have to actually do a rebuild of the Docker containers, and you can simply say that, okay, I have got the Docker container here, so you can just run one or two couple of commands and that will help you to host your Docker containers. So you don't have to redo or rework on any kind of the deployment work into the production environment or into the higher environments. And then we goes for the quick and easy configurations. So the configurations of Docker containers is quite easy. You can have your own custom Docker images built out the Docker files. So these processes can be integrated within the Jenkins also. So CI/CD is quite possible with the help of Docker if you want to really do that. And then we have better efficiency. Yes, they have a better efficiency and resources management as compared to the virtual machines. Portability, we have already talked about that it's easy to move from one environment, from one system to another. In fact, it's easy from the developer also. So from one machine, from one developer to another developer, it's very easy to move these different Docker containers. Then we have scalability. Scalability is also possible with these Docker containers. Just like multiple virtual machines, you can also create multiple containers and you can share the traffic out of that. So but that scalability and all is possible with the orchestration tools. Then security is there, so you can have your best practices of the security implemented, because it's just a kind of a virtualization, just like a virtual machine. So you have all the different possibilities which is available, which you can explore when you want to make these Docker containers secure, right? So these were some of the benefits which was there for the Docker here. Now let's talk about the installation of Docker here. Now installation of Docker is pretty common, and whatever platform you want, it's available over there. So it's available for Ubuntu, Windows, it's available for Mac operating system. So for Ubuntu, you have to run the commands on the Ubuntu operating system to download it, and for Windows, it's actually having a a particular exe file, so you can go for the installation of exe file. And then we have the Mac operating system. So for Mac operating system, you have the DMG files, and when you do the DMG file, so it will help you to install the component over there. So Mac, you can also use the homebrew once to do the installation of that particular component. Now next one is the architecture of Docker. Now, the architecture of Docker is pretty straightforward. There are key components which is available there in the architecture of Docker here. The very first one is as the client facing is the Docker client. Now, Docker client, or you can say the Docker CLI, is available there. Now, this is the component. It's a command line interface which takes up the request from the end user. Like for example, I'm running the command, so it will take all the requests from me as an end user, and it will send those particular things or the requirements to the Docker daemon, to the server, using the REST API interface. So this Docker daemon is something which keeps on running on the server, and it's a background process. It gets deployed as a service there. In case this Docker daemon is not available or it's not up and running, you will not get the proper response from the Docker command line here. So in order to get your activity or your procedures implemented, you need to have the Docker server or Docker daemon up and running. In fact, this Docker CLI can be configured to connect to any other servers or any other different server Docker daemon also. So it's a connectivity which is happening over the REST API interface, where all the requests are processed, are sent to the Docker daemon, and whatever response is coming back, that is given back to the end user. So what are the different components of Docker here? Let's talk about that. So Docker client consists of the CLI component, like we have already discussed. So that is something which is going to take up all the requests from the end user. Then it's using the REST API interface, which is there to have the connectivity with the Docker daemon. So Docker daemon is something which is always up and running. So if you run couple of commands like docker push, and also that activity, you are actually sending the request to the Docker daemon, and Docker daemon is actually doing all the work. So it's not a Docker client which is doing it, just taking its kind of interface which will take the things up and send it back or send it forward to the Docker day. Right, so it's a background process which keeps on running on the server, on the operating system, and it's the same process across all the infrastructure, all the different platforms, whether you use Mac operating system, you use Windows, or you use Linux. Everywhere this is the basic functionality, and it keeps on listening to the REST API interface. So whatever the new request comes in, it immediately processes it, and whatever the response, whether you are stopping a container, whether you are running a container, according to that the action will be taken, and the response will be sent back to the REST API to the Docker client. So a Docker is a process, or it's a command line which is used to start the Docker daemon. When you run the command like service docker status on the server, you will be able to see the command which is getting executed in the backend. So there you can see that Docker is the process, or is the command line which is used to initialize the Docker daemon. And of course there is a kind of configurations which you have to pass it on as parameters. So even if you run ps-ef command, you will be able to know that what process is running from the Docker perspective. And the third component is a particular Docker registry. So we have a ready-made cloud service which is available, known as the Docker Hub. So you can actually store the Docker images on these Docker registry. So there are a lot of ready-made Docker images which is available there, but of course you can have your own Docker image also over there, or you can have your own custom registry, Docker registries also. For example, in JFrog you can have your private hosted registries also. So all these different repositories you can use with your Docker containers. So Docker containers is having the flexibility that whichever registries or repositories you want to connect, or you want to establish the connectivity, you can always do that. Now let's talk about the Docker image over here in detail. Now a Docker image is nothing but a template of instructions. It's having a couple of instructions in which you will be using these instructions to create a final Docker container. So Docker image is nothing but for example, I want to have a Tomcat Apache Docker image. So what are the instructions I have to do? So the very first thing is that I have to pick up a base operating system. Then on top of that, I will be installing the JDK or some pre-request packages. And then on top of that, we will be configuring onto the Tomcat Apache there. So these are the steps. These are the different instructions, step-by-step procedure, which we are implementing so that at the end of the activity, we will be able to have a Docker container ready, which we can deploy to host Tomcat Apache. So it's a template which is having all the particular instructions. In order to build a Docker image, you require a file called Docker file, which is of course having all these different instructions embedded in that. So when you run the Docker file, it acts like a build tool. So whatever the instructions you are putting up over there, all those instructions are getting processed and you are able to get an end result. Then these Docker images are actually comprised of multiple layers. So multiple layers are available there. So step by step. So you will be first of all having a base layer from which the image starts. On top of that, another layer. For example, you did the installation of JDK. So another layer will be there. And then you did the configuration of the Tomcat Apache, and then another layer will be there. So it's a multi-layered in component which is available. And these layers are in incremental order. So definitely the oldest one will be known as the base layer, and then on top of that, all the latest changes will be done in the latest layers there. So this is an example. Now here you can see that there are 4 instructions, and these 4 instructions are also known as the 4-layered Docker image. So whatever the final Docker image you will get, in there you will be able to see 4 layers of the Docker image here. Now the very first is Ubuntu. So Ubuntu 18.04 we are pulling up, and then we are pulling like the file over here, and then we are running the make utility, and once that is done, then we are running that file dot Python file over here in this one. So these are 4 instructions which is available, right? So which will definitely help us to do that, how exactly we can make or we can perform the different activities right from the base. So in this case, the base layer will be like the Ubuntu one. So Ubuntu one will be the base image, and the moment the final CMD attribute or CMD attributions are processed and executed, after that you will be able to get a final full-fledged Docker image over there. So this will be a full complete Docker image or Docker container which you will get once the whole build process is completed. Now in this ways you have you can see that the previous Docker file which we processed, so the base layer is Ubuntu 18.04. we are not building that, actually it's automatically it's by default getting downloaded as a full base layer. After that only we have like layer 1, layer 2, layer 3 added up, because those modifications we are doing it after the because from does not means that you are doing any kind of layer modifications. It's just like you are importing some base operating system or base image. So the modification or adding up the layers is only done after the base layer there. So whenever a user creates a container, a new layer is something which is stored on top of the image. These layers are known as the containers layers. So Ubuntu one, the very first instruction does not comprises it. It's not a kind of container layer. We can call it as an base image layer there. So every container has a separate read-write container layer, and any modification in a container is reflected upon the container layers only. So layer 1 may be having some different of instructions, layer 2 may be having different instructions. So like that is a step-by-step process. In case whenever a container is deleted, the top layer also gets deleted over there in that one. So if I delete some particular containers, and that is something which is gone, so it was suppose having like 3 layers, so the top layer will be simply deleted because the container is also deleted for that particular part. Now Docker uses a copy on write strategy with both Docker images and Docker containers. So whenever we perform any activity, or whenever copy on write strategy is a strategy to share and copy files for better efficiency. So it's something which is being used to increase the overall performance of the Docker containers. It also makes Docker efficient by reducing the uses of disk space, because whenever required, okay, whenever is needed, only at that moment of time it's actually performing the copy, and it definitely reduces the overall disk utilization. And this is very important also, because when you have so many Docker containers up and running, so you have to worry, or you have to make the utilization of a disk or your disk users or resources also minimum. So that is also, you need to make sure that it does not exceed a particular value. So once the utilization is also less, then definitely the overall performance will also be better and improved over here in this case. So let's talk about some of the facts here. So the base layers are something which is purely read-only format, so you cannot do the modifications. Union file system saves the memory by avoiding the duplications of the files. The layers can be combined in a union file system to create a single image. So all these layers are combined and got a final product, or called a, you can call it as Docker image or Docker containers. And this allows a file system to appear as a writable, which is known as copy on write. So copy on write strategy is being used, so to do the changes, or to do the perform the modifications to this union file system while creating the different layers. So now let's talk about the Docker registry. Very important component, because even if you prepare the Docker image locally and you don't have the collaborative tool, or you don't have the tool where you can share these images, definitely it's not easy for you to port these Docker images from one system to another. So Docker registry is very important for the portability feature of Docker. So Docker registry is a service to host and distribute Docker images among users. So it can be built up by one user and multiple users can use it. For example, I'm using a Jenkins one. So Jenkins image is prepared only once, but it's being used by different people as such. Docker registry, again, it's a repository, is a collection of Docker images. So in a repository, you will be having like different Docker images as such. So in registry, a user can distinguish between the Docker images with their tag names. So for example, Jenkins is a kind of a single image. There might be different type of images there. Let's say that, okay, let's talk about Jenkins JDK8. So there will be an image called Jenkins. The name of the image will be same, but the tags will be different. So one tag could be like JDK8, one tag would be like JDK9, and one tag would be JDK10. So the difference between all these three Docker images is that JDK8 one is prepared on JDK8, it's running on JDK8, and if you want to use JDK9, in that case you have to pull down the Docker image of Jenkins with the JDK9 installed. So depending on the frameworks, or depending on the runtimes, so with these tags, different tags are processed, so you can have the distinguish between the Docker images, and whichever Docker image you feel you want to use, you can implement according to your requirement. And Docker by default is having its own cloud-based registry called as Docker Hub, which gets automatically connected when the moment you do the Docker installation. But in case you are working into your private infrastructure, so in that case you may use the repositories, Docker repositories on the specific JFrog Artifactory, or the private repositories also can be hosted. But Docker Hub is something which is having a public and private repositories both. So you can create either the public and private repositories. You can use push and pull activities to interact with these Docker images. If you want to download a Docker image, so you can run pull. If you want to push your Docker image to the Docker registry, in that case you can run the push activity. So in both the cases, you are doing the interaction with the Docker Hub. So when you run some build process, or when you run the containers, there may be some Docker containers which is getting pulled down from the specific registry from the Docker Hub, and if that specific image and tag is available, definitely pull command will be successful. But in case of push command, you are pushing your custom Docker images. You cannot push the ready-made Docker images which is available. You can publish your own Docker image only to the Docker Hub, and then you can further on do the pull and push activity accordingly to those repositories. So whatever the ready-made and third-party images which is available, you can only do the pull activities to them. You cannot do the push activities. Push command scenario will only come when you are interacting with your custom Docker image. Next one is the Docker container. Now, Docker container is an executable package of an application and its dependencies together. So when we prepare a Docker container, we actually combine both the dependencies and the application source code inside it. So the Docker container don't have to look for the dependencies on the host machine on the server. So this is one of the benefit where we see that the portability is very easy, because whatever I'm building up on one system, everything is inside the Docker container, so I don't really need to do any further activity on other machines. So whatever works on one system can be easily worked on another system. So it's very lightweight also, so it can be easily deployed and executed on on their particular servers, because it does not take that much utilization like a virtual machine. So if you are looking forward for having your application hosted into your local system, you can easily do it within the Docker container. So the utilization is very less as compared to the virtual machine, so you don't have to worry about your host operating system and the configurations. So Docker containers can run in totally isolation, just like a virtual machine. So there is no interaction, or there is no interference. So they share the OS called kernel, but the thing is they don't have the interface as such over there. So it works totally in isolation. Two different containers will not have any interaction unless and until we set up that the containers to have the interactions. Now there is data volumes which can be shared and be used among the multiple containers. So you have the capability over here that if there is some unused space that can be easily shared across the multiple containers here. So it is built using the Docker images. So using the Docker images, the Docker containers are built up, and Docker run is a specific command which is used to build a Docker container. So if you got a Docker image, let's say that I have prepared a Docker image, a custom Docker image using the Docker file. Now if I need to create a Docker container out of a Docker image, I have to run a Docker run command. So Docker run command is nothing but it initializes or creates an instance of a Docker image. Now next component is the Docker Compose. Now typically when we work with the Docker containers, so we had to run, like if I want to run like 5-6 containers, I have to initialize like 5-6 times, or I have to run Docker run commands 5-6 times there. So and if you want to create a relationship between the containers, then definitely that is something which you need to manage using the Docker commands. But sometimes it's not an easy task for you to run those commands manually or remember those commands. So Docker Compose is a utility over here using which you can actually run multiple containers with a single service. You just got a kind of a single file, you just run it, and all the containers, definitions and relationships, everything is inside this Docker file here. So you want to run 2 containers, that's totally fine. Instead of running 2 commands, now you just have to run 1 file, and that will take care of that. Now you may be having more than 2 containers, 5, 6, 7, whatever number of containers you have, that can be easily deployed without any manual activity or without any maintenance onto the server. So these containers totally run in isolation, but yes, you can establish the interaction, that how they want to interact with each other, and that interaction you can put up in these Docker Compose file. So Docker Compose file is something which is written in a YAML format, and in this you define that okay, I need 2 containers, and this image should be there. These are the parameters which you need to run, and if you want to have the interaction or the linkage between the images, that also you can establish within this YAML files, or within this Docker Compose file here, right? So let's say, for example, I want to have an application which requires Apache web server and MySQL database. Now I can create a Docker Compose file which can run both containers, and without you don't require to restart or start them separately or initialize them separately. So I will be having a final Docker Compose file which is having like containers like Apache containers and MySQL containers, both inside a single Docker Compose file here. So that's the benefit you're going to get, because now you don't have to run them separately, separate Apache and separate MySQL. So you can get it done with the help of a single Docker Compose file here. Now what exactly is the Docker Swarm? Now Docker Swarm is a inbuilt, or it's a default orchestration tool which is being provided by the Docker itself. It's a service for containers, which allows the IT administrators and the developers to create and manage a cluster of Swarm nodes. So in a typical world, when you do the installation of Docker, there is a limitation that some of the features like high availability, multiple instances, or scalability, all these things are not possible as it is with the core Docker. Now on top of that, you require the orchestration tools like Docker Swarm, where you have a swarm of node machines. 5-6 node machines are there on which you can have your highly available application infrastructure implemented. Now this one means that if I want to run my applications 5 containers, 6 containers, and 7 containers, for that purpose we are using the Docker Swarm. So each node of Docker Swarm is having a Docker daemon, which is used for performing the interaction. So there will be a master node which is available. So it will be interacting with all the node machine on all the client machines, and this interaction will be in such a way that it will let them know, okay, I want to deploy the container or onto the node 3, so it will perform that activity and the container will be up and running on the node 3 there. So a swarm consists of two type of nodes. One is the manager node and one is the worker node. So manager is the master node which you can refer, and the worker node is the one which is actually doing most of the work. So the manager node is not something which is expected to host anything apart from the main component, but yes, you can always configure if you feel that you want to only deploy the container on the worker node. So that also you can do during the deployment of the containers. So manager will keep on connecting to the different worker nodes there, and whenever new request comes in, so it will basically try to connect and see that, okay, I just want to go ahead and deploy a container. So it will do the deployment of the container on the worker node. So the main work will be done by the worker nodes, and manager is just doing the management of all these resources. The worker nodes will be definitely receiving the request from the manager, and it will be proceeding and performing those activities. And if for some reason worker node is not active or online, so the master node will not be able to deploy the containers on that server. So right now let's talk about a demo in which we have to create a Docker image using a Docker file on the Ubuntu 20. So we want to use a base operating system as an Ubuntu 20 there, and using that we are going to create a custom Docker image. So let's connect to our virtual machine and see that how we can do that. Okay, so as part of this demo here, we are going to prepare a Docker image, and in that we are going to use a base image of Ubuntu. So let's take an operating system of Ubuntu 20. 20 is the latest version of the Ubuntu operating system. So I have got a server, so let's see. So first of all, we have to install the docker.io package, which will install the Docker package, and then we can enable the service. We can make sure that the Docker service is up and running, because if the service itself is down, then we will not be able to perform any activity. And then a sample, if you run docker run hello-world, so that is going to pull a Docker image from the Docker hub, and a particular activity will be done to you. So once that is done, so we can say that, okay, the container is up and running and everything is got over there up and running. And then you can also try some of the Ubuntu Docker image also. If you feel that you want to try, you can do that. But the main demo which we need to do over here is that we need to prepare a custom Docker image, and in this one we will be having we will be using an Ubuntu base operating system. On top of that, we will be installing PHP, Nginx, all these different components. So we are going to have a PHP based website hosted onto the Apache web server as an Nginx, and then we will be able to access that application. So the very first thing which we need to do is that we need to create a folder. Let's say that I just create a particular folder called nginx-image, and then I create a Docker file over there. So Docker file content we are going to take from this one. So let's go to the server and see that how we can go ahead with the activity. Now what we can do is that we have got a server over here. Now in this server, what I'm going to do is that I'm going to proceed with the installation of Docker first. Now when I do the Docker installation first, so what will happen, that I will be able to have my Docker installation completed, and then further on I can take the further steps of having the accessibility of going through the understanding that what is this particular platform, or how to prepare different kind of containers. So I have got a particular container over here. So what I can really do is that I can simply say that, okay, I have got a server. So this is a Ubuntu server, so I'm going to run the command called app update first. Now this will do the update locally, so all the links and everything will be updated. Now the whole idea about doing the updates is that so that I will be able to have establish the fact that I'm trying to connect connect to the Ubuntu URL, so that at any moment of time I should be able to fetch on the latest packages. Now once that is done, so I'm going to run the command called apt install docker.io. Now the moment I do this, what will happen that it will try to download some packages. It will ask for the confirmation. You can give your confirmation and I can say yes. The moment you give the confirmations, the download of the packages will proceed over here. Step by step it will download the packages and the installation will go on. Now once the installation is done, so what you can do is that you can see that Docker is deployed into your system or not. You can run docker version command, or you can also use the service command to check, to make sure, to ensure that the Docker service is always up and running. If the service is not up and running, you have to make sure you have to enable it, you have to start that service. So these are some couple of steps which you need to do in order to make sure that your connectivity or your environment is ready for with the Docker installation. And once the Docker installation is done, then only you will be able to proceed further with the further activities like preparing the containers, preparing the images and all that stuff. But if you don't have the Docker installed prior to that, then definitely it's going to be a problem. So just make sure that before even doing any kind of activity, before even doing any kind of steps, we ensure that the Docker is fully up and running. So it's going to take some time to download the packages, and we will wait for that. And once the installation is done, we will continue further on that part. Okay, now once the installation is done, so you can run the command called service docker status, and when you do that, it will let you know that whether the Docker service is available there or not. So you can start the service in case you don't get the proper response. And now you can see that it's showing up that a process is running. So earlier it was not up and running, it was inactive, but now it's active. And you can see here that dockride is the process which is running over here as a process to initialize the Docker daemon. So Docker daemon is up and running now, and we are good to go here. So now if we go and say like docker run hello -world, so we are doing a validation to our Docker instance that whether our Docker instance is working fine as expected or not, because if there is any kind of problem with the Docker daemon and Docker daemon is not up and running properly, we would be able to get an error message over there. But right now there is no error message, which represents that yes, you are pretty much running the Docker image and it's giving you the proper response. So you will be able to see the Docker images when you run. So you will be able to see that the Docker image is pulled down to your system, and definitely you have executed that and it got you the response. Now the next thing which we need to do is that we need to run a particular Ubuntu one. So for example, if I go for docker run -it Ubuntu bash. So what exactly we are doing in this one is that we are pulling down a Ubuntu Docker image and we are running the bash executable on top of that. The whole purpose of doing that activity is that so that if I want to do some process or I want to perform some activity, I should be able to connect to that Docker image. So the moment I do this, first of all, if this Docker image is available locally, that's great. It will immediately create the container. If the Docker image is not available locally, the very first thing which it will perform over here is to pull down the Docker image, the correct one. And as you can see here that it definitely pulls down a Docker image, and once it is done, so it got a terminal for you. Now you can see it shows that root at the ID root at the rate 1 ID is there. This ID is nothing but it's a container ID which we are getting here. So definitely you are inside the Docker container, and when you run the Docker when you run the exit command, you will see that you have come out of the Docker container over here. And the moment you run docker ps-a command, you can actually see also that how many container you deployed so far. So you ran hello world, you ran the Ubuntu one, both of them are stopped there. You can see the exit 0 in the status over here. because both of them are something which you ran in the interactive mode, so they are done. So if you want to keep your container up and running, you need to have a container which runs in the dash mode and always up and running. But for that, you have to go ahead to the level where we need to create a custom Docker image and do the setup accordingly. So let's see that how we can do that. Now I'm going to create a particular folder called nginx-image. You can pretty much give any name, whatever name you feel you want to perform, you can do that. Now in this one, I'm going to put up a file called docker file. So let's see that what content we need to put as such when we talk about the docker file, because whatever content you put over here, that is what according which the docker image will be prepared. Now here we have to talk about, so first we have to see a base image. So we are saying that okay, Ubuntu 20.04 is what I want to use. Then we are giving some labels. Now these labels are used to give some information like what is the version, who is the maintainer, what is the description. You can do the customizations to this one. So these labels are actually defined and utilized so that I will be able to give an information that okay, so and so developer is something which we can contact. So if there is any kind of problem with the docker file or with this build script, we have to reach out to that specific person. So this is what we typically do with the labels here. Now we also have to set up a parameter like Debian_fronted as in non-interactive, because whenever we talk about any build process in Docker file, it cannot be there in the interactive session. It should be there in the non-interactive. And definitely a typical scenarios like you can run app update command, and then we are installing the PHP, Nginx, supervisor, all these things we are doing the installation. We are using the run attribute, run a particular step, and in there whatever the commands are executed, these statements will be executed when we will be doing the build process. And then we are using some environment variables. Okay, so nginx virtual host, php_conf, nginx_conf, and supervisor_conf. These are the different environment variables which we configuring over here. Now next thing which we have is that we have to transfer some files like probably nginx and the virtual host file. We may have to transfer from a Linux server to the destination to the Docker container. So for that we are going to run some copy commands, copy statements, so that we can do that stuff. And then definitely we are transferring the supervisor configuration file also to the server, so that we can have that configurations set up over there. And these supervisor_conf and all these different variables we have already established, where we are saying that what exactly configuration we are looking forward over here. And then we are creating some folder structure. We www.html folder structure we are creating, so that we will be able to push some content over there. And then we have the volume configurations. So whatever the volume configurations are there, we are putting up, so that we will be able to have all the specific directories mounted on the host machine, on the host server, so that we can even talk about locally also. And then the star.sh is something which we need to run, because that will go into the command statement which needs to be executed. Because when you want to run your process, when you want to run your nginx process or your Docker container, some process should be up and running. That's where if any interactive process will run, then only the Docker container will be hold up. So that's what you can do or you can configure over there. So I'm going to copy this whole content. Now this whole content represents the complete Docker file. So we have already gone through this content one by one, but if we combine all these content together till the expose part, that's where we come up into this one. So expose, we are doing 80N443 over here, right? After this one, we have to create the host file, virtual host file, supervisor d file, and the star.sh file. So let's go back to the server here. Now in this one, you have to you can use whatever editor you feel you want to use, you can do that. So this is what my master file will look like. You can see I'm running some run commands. These are the environment variables I'm using. Then further on, these variables I'm using just to define the paths. Okay, so you can see that this default file we are copying from the host machine, from the server to the Docker container. And then second file is supervisor d.conf file, and then we have star.sh file. So these are the different files which we want to configure here. So once this file is prepared, we have to type in, or we have to create a default file over here in this current directory. So in this current directory, we have to put up a file called default. Now in this one, we will be having the default virtual host configuration config. So we need to put a server attribute saying that we have to look forward for index.html or index.php and these kind of files from the var www.html directory there. So I'm just going to copy this content and put it up into this one. So this is how my final file look like. So I'll save it. And then we have a supervisor.d.conf file. So I'll just copy the content of this one. I'll copy it, and we have to create a file called supervisor.d.conf file. Now names we can double check because we are referring these names into our Docker file, so we can double check that. So once this is done, save it, and we can check the Docker file. We can grab, so you can see, okay, this one, so supervisor D, so the name is correct, that's cool. So we got a default, we got supervisor D. Now we have to create the start.sh file, because in this one we will be configuring that how we want to start our process of this Nginx or this web server. So in this one, again, we have to run the supervised process over here and a configuration file. So we are going to put this one, and we'll go here and put this content. Right, so we got the supervised config also available, so that's also there. And the moment this is done, so you are going to give the execute permission to this one, because you can see that into our Docker file that we are having the attribute where we want to run this into the slash there. So if you want to refer in that mode, you have to change the permissions, and case so that change mode, you have to give the execute permission to the start.sh here. Now once this is done, so what you got is that you got a particular components, like you got some couple of commands, you have got Docker file, supervised.conf default, all these files are there. Now the only thing which we need to do next is that we need to do the build process. So if we look forward for the build process, so what happens, the Docker build is the command which we need to use, and nginx-image is the name which you want to refer. Now you can totally use this custom name, whatever name you feel that you want to use, you can always use that. There's no restriction on that part. And once that is on, so you will be able to list down those images that you got a new custom Docker image here. So you can see that you got the Ubuntu as a base image which is built down, and the nginx-image is also prepared over there. And once that is done, so you are going to create a webroot folder, and you can run the docker run command to see that if you really got connected with that particular one. So let's go back and see that how we can create the custom Docker image here. So the moment I do this, so it will pick up the Docker file over here and start performing the activities, the package installations, all those configurations ones will be performed over here in a non-interactive mode. There is no confirmation which will be asked from the user, because you cannot put that confirmations. So the command should be in such a way that it should not take any kind of confirmations at all from the end user. So because tomorrow you may be putting up these things in the Jenkins, so that will not be a feasible thing for you to put up the commands and put up the confirmations during the execution. So it's trying to do the package installation for the PHP. So fpm packages are getting installed, and here we go. So we got the successful message. Now you can see it says successfully tagged this one. This means that there is no issues at all with the Docker image, and when you run the Docker images or Docker images ls, you can run these two couple of commands. So when you do that, you got a 237 MB of the size of this image. That represents that this Docker image is fully ready to run to execute. So Now what we are going to do is that we are going to map a volume over here with the var www.html directory during the execution of this container, because I really want to deploy some pages, some web pages there. If you have the web pages now as part of the build process, as part of the Docker file, you can do a git clone also of some repository, but I don't want to do that during the preparation of Docker image. I just now got an environment where the Nginx is set up properly and it's up and running there. Now it should be upon me that how I want to put up my content and all. So that's the reason why I'm putting up a kind of a folder structure over here and sharing it with the Docker container, so that the moment I put that the HTML files or the PHP files into that local folder, I should be able to get some web page up and running there. So that's what I'm going to do over here in this one. So I'm going to create a folder structure saying slash web root here. Okay, so there is a folder structure which is created. Now in this web root I will be putting up some files, and then same files will be redirected inside the Docker container with the help of Docker volume. So let's go back to the document. Now here you have to run the once, like I said, that you are going to connect on that part. Okay, so you can use this port as an AT also, but here 880 is used, so whatever port you feel you want to use, you can do that. And we are giving the container name as test and hyphen container, that also you can change. And Nginx hyphen image is the one which we are using, so if you use some different particular image, you can also use that. And you can see that the web root is something which we are connecting with the var www.html directory. So the moment you put some file in the web root, the same file will be reflected into the var www.html directory there. So I'm going to run this command, and once this is done, so you can see that for the testing purpose we are putting up some content in the HTML1. So I'll come to that point also and we'll validate. As of now, we should be having our container up and running over here in this one. Now I'm going to copy that command, okay, and hit on. So if the 80 port is used, so you have to make sure that port gets gets stopped automatically, or it should not be up and running. So just double check whatever port you are using, that should be free. Now when you run the docker ps command, so you will be able to see a Docker container up and running. But if you see like docker ps-a, that gives also the stopped and running, both the containers are there. But the main thing which we want to run is that we want to run the docker ps command, and you can see that this is a container which is running. So 8080 is the container which is running, and test-container is the name. Now you got a container up and running, so you can actually do a curl on localhost colon 8080. So this is a way to get the content. You can get the public IP also, and in the browser you can put up and you can have the content there. But right now we are getting the response, at least it's showing as 403 error, forbidden error, but that's fine. We will be putting up some web pages there in the var www.html directory, or we can say in local web root directory, so that we will be able to have some content. So what we can do is that we can have some echo commands executed, so that we can have some content added up into the particular files there. So let's see that what different contents we can do. So you can use the vi mode also to do a couple of files. So I'm just using this echo command. So the moment I go for this execution, so what happens that a file will be created into that slash web root there. So I'm expecting that I have put up a index.html page. So if you feel that you want to put some different page, you can always do. And the moment you do the curl, now you will be able to see the same response. So whatever the things you put up in the index.html file, the same content is going to pop up when you run the curl command. Now you want to use some PHP files, you want to put up some PHP content, all that stuff you can do it. Now what I'm going to do is that rather than just HTML static content, I'm going to put some PHP content that is going to help me to get a file. So my web root will have now two files. So if you feel that index.html file should have some meaningful content, you can always do that. You can pull some of the websites also, you can put that into the, you can do a git clone in the web root, and the whole application will be started. And now if you feel that I got a info.php file, so I can use that name into the URL. I have to modify the URL because index.html file is the what as in default name page you do. If you want to put up some different name, you can change the server configuration of Nginx, and according to that it will work. So when I do this, so you will start getting the output. So this is the PHP content output which is there. It's a complete information. Now it may look like a very bulky content to you, but when you put up this one into the browser, into the web browser, that will be a meaningful information, probably in terms of some tables or something like that, right? So let me scroll to the top here, so you can see that it's showing an error. Sorry, it's showing in the output, and this output represents that you got a particular PHP content here. So this is how we will be able to have a container, and this container is up and running. You can modify to at any level. You feel that you want to prepare a Docker image with the code embedded also, you can have the git clone, or you can have this configuration into some git repository, have the source code also there, and then prepare a complete bundle altogether. So this is what we have in this demo, how we can deploy a container and a container up and running in case of the Docker here. So that was the demo, right, which we took to create a custom Docker image on using the Docker file on Ubuntu 20, right? So that's it for this lesson. Thanks everyone.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.